All right, this is a new concept that we haven't talked about yet, and it's called systems of equations. So it is going to involve equations of lines like we have done thus far, and we're going to be looking for a solution, and so I will show you what I'm talking about when I say a system of equations. So a system is something that works together. With systems of equations, it's a system where two equations are working together. And when systems work together, you usually end up with one solution. And that is the case with systems of equations of lines. So in this case, we see here a line, this red line I just highlighted, and then this blue line that I just highlighted. And if you notice, these two lines intersect at one point. And it's labeled here as 2, 1. And that is really as simple as it gets. When you have two equations that are working together in a system, they have one solution, and it is marked by a coordinate pair as follows. So if you notice here, this 2, 1 is where the two lines intersect, and that is where the two systems work together. So I'm going to go ahead and scroll to the next one, and you can see what another system of equations could look like. And as we're going through these, or you'll be able to see this PDF on its own, there are going to be 20 questions that we go through as a class today, or so if you're at home, you'll want to get a piece of paper out and work out these 20 questions on a piece of paper. So here we have another two equations that are put together in a system. So where would these two systems meet? Or what would the solution to these two systems be? All right, and so I hope you see that it's going to be right here at 5, 1. All right. Number 3. And I'm going to go ahead and now you see how to find this answer to a system of equations, how to find the solution. I'm going to go ahead and skip through the other ones, but on the PDF, or you can pause this as I stop at 1. All right, so the next thing that we need to talk about in preparation for the test is something called intervals, and I know I've mentioned it before, but an interval is a counting system on a coordinate grid, or there's other definitions of systems. But if you notice those black lines I just drew, these are where we indicate the counting on a graph. So normally we assume that these are 1, 2, 3, and so on, 1, 2, 3, -1, -2, and so on. But sometimes the information needs to be plotted differently, and the graphs, the amount, I guess, that needs to be covered is larger than 1, 2, 3, 4, 5, 6, 7, 8. So sometimes they'll use numbers like 20. And so if that first line is indicated by a 20, obviously we can't assume that this next one is 21. That just wouldn't make sense, because if the first line is 20, the next line would have to be 40 and 60 and so on. And then on the x-axis, it does not have to be the same. Sometimes it is. Sometimes it could be 20, 40, 60, but other times we might even have a 1, 2, 3 on the x-axis. The x and y-axis do not have to correlate, so we need to take into account when we're finding slope that if I choose to have a rise of 20, and my run could be 1 in this instance of what I just drew here. So mostly I just want you to be aware of intervals. I think you understand what they are, but sometimes we overlook them because we assume that it's just every graph counting by 1. So I'm going to place an interval on here. And I'd like you to now pause the video and find the slope of this line with these given intervals. Okay. So again, looking for the rise over run with found pretty points. Okay. So the next thing we need to cover is something on stories and graphs. And because obviously we're not always just going to be given y equals 3x plus 4, and that's the only thing you're ever going to have to do, and then you have to put it on a graph and so on and so forth. Sometimes we're going to have to be given real life scenarios where this concept of linear equations would be input. So let's do that with this first example. So it says Lenore pays a total of $16.50 for every 6 shirts she has dry cleaned. Which graph models a relationship with the same unit rate? So first, unit rate is the same. This equals slope. Okay, so which one has a slope of, for every 6 shirts, she makes $16.50. So we're going to take a look at each of our examples. So in this case, for 1 shirt, she pays, looks like just under $4. So it's not, so first actually, what would be important to figure out is that, for 16 shirts, $16.50, we need to divide that. So that is our slope that we're looking at, because it's money per shirts. So we're going to take the money is going to be on the y-axis, and then shirts is going to be on the x-axis. So what we could do is go over to 6 and see if at 6, which one has $16.50. So if we see here, the only one that has that is this one. So I think a lot of times people will think that 1 shirt was $16.50, and if you notice that on this one here that I have my laser on, this one has 1 shirt being $16.50, but in the problem it's saying that she pays $16.50 for every 6 shirts. So you kind of just have to pause and think about the story before selecting a graph. And so that is that. Okay, another one. So pause this. I'm going to have you choose one, write it down on your paper. Again, Joseph running 6 miles, pause, write it down. All right, this one says, Coach Wallace is ordering track shirts. Coach Wallace pays a one-time fee of $37. He also pays $7 for each shirt ordered. Write a function that can find C, the amount Coach Wallace pays in dollars when K shirts are ordered. So we have a C equals, so this is kind of going to be like our Y equals. So we're looking to write a Y equals mx plus b type equation, where our slope is going to be a K, which kind of makes sense because if you ordered 0 shirts, anyway, so we have K shirts ordered. So the one-time fee, that's going to be something with or without a variable. So hopefully that's what you said is going to be without a variable. So that 37 is going to be, if he orders no shirts, he's going to have to still pay that one-time fee of $37. And then on top of that $37, he's paying $7 per shirt, which is the K. So that is how you kind of take words and extract them to put them into a equation type answer. So go ahead and let's try this one. So this one says the table shows the linear relationship between the number of hours Mr. Campbell worked, X, and the amount of money Mr. Campbell earned, Y. So for 1.5 hours, he earned $24. For 52, $3.25, and so forth. So the question is, how much money did Mr. Campbell earn per hour? So this is where we can think about it being a proportional relationship and dividing our y by the x, since if he worked 0 hours, it would be $0. So that would be proportional. Okay. And solving equations is something that we have definitely covered so far. And so I want you to pause, and I'm going to work this one out here. So first we need to combine our like terms. So I'm going to box my variables and circle my constants, and I know that this has been a long time since we've done this. So we can only combine on the left and right. We're going to combine our like terms. So 6x minus 3x is going to be 3x, and then I don't have any other constants. And then I can take 4 minus 10, which is going to be a negative 6 plus x. So then from there, we're going to combine our least coefficient, which is 1. There's a 1 here. So I'm going to subtract 1x. I'll just put a 1 there so we can see it. So on the right, that becomes 0, and we're left with 2x plus 4 equals negative 6. So then here, we're going to take our constant that's on the same side of the variable and move it to the other side. So now we have that becoming 0, and we're left with 2x equals negative 10. And then our last step is to divide by our coefficient, which is 2. And that leaves us with x equals negative 5. So those are the steps: combining like terms on both sides of the variable, combining like terms, moving our least variable, moving our constants on the same side as the variable, or same side as the equal sign, and then dividing by our coefficient, which ended at our answer of x equals negative 5. So now here are some equations for you to solve on your own. Okay, so take a moment, pause. Number 12, 13, pause, solve, pause, solve, pause, solve. And next we have writing equations. So again, taking words and putting them into things, and this is what we need to take into account. These were our notes from this section. So taking into account what equates to a variable and what equates to a constant. So here we go. We're looking to write and solve each of these. So remembering that if this was, so we have, here we got Peppy Pets, which is a flat fee of $15 plus $3 per hour. And then Happy Hounds charges a flat fee of $21 plus $1 per hour. So then from there you can solve your equation. So because we're looking for when the two companies will be the same. So that is why we can set them equal to each other. All right, we have a water tank, 18, 19, and 20. All right, and the last thing that I would like to cover is these few equations that will help you out. And we have this called error analysis. So I want you to look at these next couple of problems and find out where I went wrong in solving this equation. Okay, so there's a couple of those. 1, pause. 2, see if you can find my mistake. pause, 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 and I think that is it. Okay, all right, well, hopefully you were able to get those done and feel more prepared, because things like this will be on the test.